Hello everyone, welcome to another video. In this video, we're going to code binary search in Python. Binary search in Python, we're going to do it a little differently. Yes, we will code this, but what I'm going to do is use series of print statements and using input function to kind of stall the program so that we get to see what's going to happen step by step when we do search for value in this list of fruits that we have. And so first and foremost, we're going to get this binary search code working, and we'll be returning -1 if it's unsuccessful. So we're going to say we have a left variable 0, and it says right variable is equal to n-1, where n is the length of our list. So we're going to say length of our a list -1, like that. And it says while left is less than equal to r, we're going to do the following. So we're going to write that code. We're going to say while left is less than right or equal to right, we're going to do the following code. We're going to say that mid is equal to the floor of L plus R divided by 2, which is left plus right, all floor divided by 2, like so. And then it says here, if A at M is less than T, we're going to do that, and so on. So it says here, if a list at our midpoint is less than our target value, when we compare them, we're going to have to say that our left gets increased to mid plus 1 because we don't need to now worry about the left side of the midpoint. Else if we're going to say that a list at mid is greater than the target, then, well, we don't need to worry about the right side. So we're going to say that right side is equal to mid minus 1 instead of relying upon the length of our list minus 1 for that point. We have updated left and right here. However, if we found out that a list at midpoint, or whatever that value of mid is, that means we have successfully found where our target is located, so we can return the value of target, and it will exit this loop for us, and it will exit the function for us. And if we were to end the while loop when left ended up becoming greater than the right value, we're going to return -1, which means not found. Okay. Now our function is built. We have followed the pseudocode properly. Now we're going to try to test it. So let's run our code. Okay, so I'm going to enter like say Kiwi. Okay. A list is not defined. Oh, sorry. We were going to do fruits. Let's try that again. We're going to do Kiwi. And Kiwi is located at Kiwi. Oh, we return target instead of our mid value. Fantastic. Let's try that again. We're going to go Kiwi. And it's at index 28. So let's see here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Perfect. You know, it's relatively working. That's how we checked it. All right. It should be working because we did follow this, the pseudocode directly. And that is how we do a binary search, where we always start from the middle and then look at the left and the right side continuously over and over again until we found it, or we end up getting a variable where the left side is greater than the right side and we can return -1. So for example, if we were to run and look for carrot, it's going to not be found because there is no carrot in this situation. Now, what I'm going to do is, well, if you're having trouble understanding this binary search algorithm, we're going to be displaying what is happening throughout my binary search. So we're going to be doing a counter equals 1. So we're going to say that print, we'll do an f string. We'll say iteration 1. Left value is left. We'll do that like that. Right value is right. Okay, and then let's make this a little nicer for printing. Right value, iteration, and we're going to say this is a counter. And we're always going to increase counter by +1 here, just for testing purposes. Okay. And And after our mid value is printed, we're going to say that if mid is mid like so. And then what we're going to do is fruit at mid is going to be a value of a list at mid. And we can write an input function here and so on. Here we go. We'll run this again with Kiwi. Now, as you see, we haven't done anything. Our left value is at 0. Our right value is at 49, which means that there should be 50 values in total with indexes of 0 and 49. And it calculated that our mid value is 24. So it calculated, and we were looking at that a list at mid is currently honeydew. Okay, well, for us, okay, honeydew, where's honeydew? Honeydew's right here. Honeydew comes before kiwi. That means a list at mid is less than target. Left is going to be equal to mid plus 1. So 49 plus 1. So if I were to press enter here, in our second iteration, left value has been updated to 25, right value didn't change, and mid value is at 37, and fruit at 37 is orange. So this at 37 index, we have the orange value, and that is greater than our target value because kiwi comes before orange. So we're going to now say that, well, right is mid minus 1, where mid is 37. So we're going to now do our search of our binary search again, starting from 25, but we're only going to go up to 37 minus 1, which is 36. So if we do it on our third iteration, we're going to say that left value is at 25 and right value is at 36. So the midpoint is 30, and fruit at 30 is lemon. Okay, so we're right there. So we still know that, well, lemon is greater than kiwi. So we need to update our right value to be 30 minus 1, which is executing this section of code right here. So if I were to press enter and do another loop, we get to press enter because we have stalled our program by doing input. At fourth iteration, left value is still 25 because we've been consistently getting the greater value than kiwi. And then our we have calculated that our left value is 25, right value is 29, our midpoint is 27, which is here, and we got Jambool. I don't even know what that fruit is. And that point, well, Jambool comes before kiwi, so we need to actually update our left value to which is 25 to be mid plus 1, which is going to execute this code. So on the fifth iteration, we got that, well, 27 plus 1 is 28, so our left value is 28, our right value is 21. So if we're to add those two numbers up and divide by 2 floored, we're going to get mid value of 28, and which actually targets kiwi, and it's going to return that value, and we get to output that kiwi is located at index 28 thanks to this print statement right here. Okay, and that is how an example of how this binary search would work. And this is how you can also use print statements, inputs, and maybe add counters, add other variables to your code to test and debug your code as well. As always, thank you for watching and stay classy.